Good morning, everyone, and a very warm welcome. We are delighted to have you all join us for today's webinar on surge protection devices, a topic that plays a vital role in ensuring safety, reliability, and efficiency in modern electrical systems. My name is Lakshmi Venkat, and I'll be your host for today's session. In this webinar, we will explain the importance of surge protection devices and learn about their applications in safeguarding equipment infrastructure. Today's webinar is an initiative of Cape Electric Private Limited. Before we get started, just a quick note. Please feel free to share your questions in the Q&A box only. We will have a dedicated Q&A session towards the end of the session. We have two eminent speakers for the day today. Mr. Vijay Kumar Singh, National Manager, Business Development, Cape Electric Private Limited. Mr. Vijay Kumar Singh is a seasoned professional with a BTech in Electrical and Electronics Engineering and over 12 years of experience in the field of lighting protection systems and electrical safety for healthcare facilities. He is skilled in designing, auditing, and maintaining resilient electrical infrastructure for hospitals, ensuring compliance with IEC 62305, NBC 2016-2016, and the healthcare safety standards. His key expertise in ELPS design, verification, risk assessments, grounding, earthing, and surge protection, electrical safety audits in hospitals, ELPS for tertiary hospitals and trauma centers, insulation monitoring, and medical IT panels group 2. Our next speaker is Mr. Anandu Gopan. He's an application specialist at Cape Electric Private Limited with expertise in EMI EMC design for buildings, transient analysis, and interference studies. His work integrates practical engineering with research-based insights to strengthen electromagnetic compatibility and safety. He contributes to standardization efforts as a member of BIS Committee ETD 20 Electrical Installations, ETD 30 Surge Arresters, ETD 50 LVDC, and IEC Working Committee Groups, TC 64 MT3, TC 81 MT3, MT8. He pursued his master's by research on transfer potentials. He is dedicated to advancing safety and reliability in electrical systems. Also, our keynote speaker is Mr. Gopakumar. I would request Mr. Gopakumar to give a keynote address about the topic for the day. Over to you, sir.
So, I hope my screen is clear and visible and the sound is good.
Yes, sir. Yes, sir.
Thank you, Lakshmi. Good morning, all participants. Today we are going to have a webinar on an interesting subject, which is SPDs. I would like to explain a little bit history of how SPD started in the Indian market. I mean the low voltage surge protective devices. The first SPDs in India came along with the imported machines during 1995-1996, mostly along with the wind turbines. So it started as a protective device in the wind turbines. Later, during 1998 to 2000, SPDs were part of power supply. The Telecommunication Engineering Center, TEC, they made SPDs mandatory in the power supplies, the SMPS power supplies of telecom. As a result, people started using SPDs in the market. In 2003 or 2002-2003, the RDSO, Research Development and Standards Organization of the Railways, they made a new standard for using SPDs in railways, which is a part of IPS, Integrated Power Supply. So basically the market started during 1995. Before 1995, there were so many players, but there was no standard way of using SPDs existed in India. By the starting initial days of 2000, of course, people started realizing the importance of SPD. I still remember one of the site study which I made during 1998. It was in a paper mill where the drives were tripping due to the switching operation of the capacitor bank in the distribution company's substation. So we could solve the problem with the SPD. This was a great achievement during 1998. After that, we were continuously doing several failure analysis, especially electronic equipment failure analysis, and we were installing SPDs. During 2004-2005, the market really started because of the telecom boom. During 2006-7 or something about 2008, we were supplying SPDs in quantities of thousands, in fact, 10,000s, because that was the time the telecom was in boom. 10,000 sets of SPDs for telecom companies, maybe in every 2-3 months, 10,000 sets. That was the volume which was going. Parallelly, over the last decade, a lot of low quality SPDs came into picture, especially made from the imported from China, putting some brand name, and since SPD is a passive device, you really cannot find out whether the SPD is working or not. As a result, even if you put a stone inside an SPD box and put it, sometimes people believe that this is an SPD. So that much, the quality depletion started in case of SPD. During the initial days, there were two type of SPDs which was mainly used for power line. Type 1, or it was called as Class B at that time, which was a spar gap based SPD. And there was a MOV based SPD, which was Type 2. I would like to show you an interesting video of a small, a small video of how the type 2, the spar gap SPDs were working. You can see in this particular movie, this is a spar gap SPD. During the initial days, the spar gaps SPDs were exhausting type. Exhausting type means the spark which was created inside the gap, it was blowing out. They were also called as blowout type SPDs. So spar gap SPDs were highly dangerous during that time. But over a period of time, the RDSO was the first one in 2003. They have specified that only encapsulated spar gaps are allowed in railways, and over a period of time, a lot of developments happened. Now today, one of the challenge the market face is the length of the the wires which is used in SPDs. Majority of the customers, the users, don't care about the length of the protective conductors, the wires which is used to connect the SPD. As a result, SPD, the effectiveness of SPD is quite less. Anyway, the speakers will explain more about this. So SPD is a vital component in lightning protection or protecting electrical and electronic equipment in your building. I wish a nice and an informative webinar today. Thank you very much, Lakshmi. Over to the speakers.
Thank you for the introduction. Now let me share my screen. Yes. I hope my screen is visible.
Yes.
Yes. Yeah. So Lakshmi has already given a small introduction about myself. So let me just make it really short. So I'll be explaining about surge protective devices, and in the left side of my slide, you can see the standards which are related to the surge protective devices. So first one is IEC 62305, part 3 and 4. IEC 62305 talks about lighting protection, and part 3 you will find SPDs in equipotential bonding, and part 4 you can find it for protection for internal systems. IEC 61643 is the main SPD standards. So in this you can find 11, 12, 21, 22, 31, 32. In the future you can also find 41, 42. So basically 11 and 12 is for low voltage SPDs, power line SPDs. 11 is for testing, 12 is for usage. How to, what is the application? How to select, erect an SPD. 21, 22 is for telecommunication or data line SPDs. 21 is for testing, 22 is for selection, erection of an SPD. 31, 32 is for a PV SPD, 31 is for testing, 32 is for the application. And parallelly for low voltage electrical installation, IEC 60364 or our IS 732, you can find it in 553 about how to use an SPD. Now, jumping back to our topic, let me just stop sharing my screen, sorry, my video, and then we can have a better bandwidth. In IEC 62305, we have part 1, part 2, part 3, and part 4. So we will be discussing majorly on the part 4 or some parts of part 4, and then we will be covering on the 60364 standards. So in part 4, SPD is a big subject because we are talking about internal protection. Internal protection means protecting all your equipments which are inside the building. And for that, to achieve equipotential bonding, that we need SPDs. And we select SPDs based on two things. One is lightning protection level. Next is lightning protection zones. So at every zone entry, we will be having an SPD to further reduce the surge currents which are entering your building. Now, before I jump to this topic, let me explain some basic principles about SPDs. We have two wave shapes or two current wave shapes. One is 10 by 350 and next one is 8 by 20. So 10 by 350 is for direct lightning current and 8 by 20 we consider it for coupled or indirect lightning currents and switching surges. So a 10 by 350 looks something like this. So at 10 microsecond from the zero, at 10 microsecond it will reach 90 to 95 percentage, 90 to 100 percentage of its peak surge current. So if it is 100 kA, at 10 microsecond it will reach 100 kA, and at 50 microsecond it will reach the half of that. At 350 microsecond it will reach half of that 100 kA. So 50 kA you will reach at 350 microsecond. And parallelly you have 8 by 20, which is for indirect lightning surges. Same concept. At 8 microsecond it will reach the peak, and at 20 microsecond it will reach the 50% mark. Now, this wave shape is used to define how an SPD is tested and erected at your building. Just to clarify, 10 by 350 is for direct lightning strike, and 8 by 20 is for lightning near the building or any indirect or a partial current flow due to lightning. We will call it as 8 by 20. And then next one is switching surges due to the SPD. So what happens when your SPDs are not there, or what happens during a lightning strike? Basically, you can have an insulation failure or degradation of your insulation. So there is a lightning strike, but you don't see an immediate failure in your system. But what happens is your insulation is stressed and there is a small degradation. So over a period of time, maybe after 5-6 days, maybe 10 days, or maybe in a few months, you will the insulation is stressed, and then you can have a fire and all these things. And then again your electronics will be destroyed. So how do we select an SPD, or why do we provide an SPD to your building? So you know that in our building there are four categories. So category 1 or category 4 is at the mains incoming. So your power meter, your MCB, your MCCBs, all your circuit protected devices are tested for an impulse withstand voltage. So this impulse withstand voltage is 6 kV for your mains incoming. Okay. For your fixed installation in the sense lights, maybe even some ACs, TVs, any other fixed installation, fridges are tested for 4 kV lightning impulse. And then connected device is tested for 2.5 kV. Connected device in the sense any device which is directly plugged into your wiring system. Maybe, sorry, a TV, your machines, any machines which are directly plugged to your system. It is tested for 2.5 kV. And then we have a third category, category 1, which is not directly connected to the low voltage supply, and it is tested for 1.5 kV. So we are providing SPD so that our uh, this category is achieved and SPD is within this 2.5 kV or maybe even 4 kV impulse voltage. So in lighting protection, we have something called as zones of protection. Zones of protection means at or at zone 0 there is a direct lightning strike, and inside zone 1 there is no direct lightning strike, but maybe some the indirect effects of lightning can be felt. Zone 2 is where the effects are little bit reduced compared to zone 1, and zone 3 is where the effects are furthermore reduced. So whenever we design a lightning protection system, we have to define the zones, and depending on the equipments which are used, we have to categorize them whether they are safe to be used in zone 1, zone 2, or zone 3. So there is a wonderful presentation which CAPE has done to NFE in the uh, YouTube. You can find that. Now, type 1 SPDs will be used in zone 0 to zone A. So you can find type 1 SPDs to be used here. Type 2 SPDs will be used at this location, zone 1 to zone 3. And the type 3 may be used at this location. Basically, type 3 SPDs are used for more critical equipment, maybe for a server rack, uh, and they should be located 10 meters within 10 meters from the computer or this equipment. So type 1, type 2, and type 3 for power line SPDs. How do we select an SPD based on the sources of damage? So for example, for lightning, we have 4 sources of damage. One is direct lightning strike to the building. You can see here, there is source of damage S1. That means direct lightning strike to the building. S2 means lightning strike to nearby the building. So you know that there will be a GPR increase inside the building, and there can be a surge current flowing through it. And then lightning strike to the power line and to the nearby of the power line. So source of damage S3 and S4. So for this condition, for example, how do we define S1, S2, S3, and S4? Basically with the risk assessment. So risk assessment will say whether you have a chance of direct lightning strike to your building, or if there is not a direct lightning strike, but you have more probability of S3 and S4. Okay. Now, um, suppose risk assessment says that you need both lightning protection and surge protective devices, that is considering S1, S2, S3, and S4. We will need to provide an SPD at the entrance of the building. You can see here at the entrance of the building. One more SPD at the closer to the equipment. So it will be a type 2 SPD so that it is tested for 8 by 20. This will be 10 by 350. And then one more SPD, this SPD, which is tested for 10 by 350 because you have an antenna which is protruding outside the building. So because there's an antenna protruding outside and there can be a direct lightning strike here, we can expect some partial lightning currents to flow through the SPD. So we'll need a 10 by 350 data line SPD at this location. And then if your risk assessment says you don't have any lightning damage to your building and your building is safe from lightning damage, then considering source of damage as S3 and S4, S3 and S4 is direct lightning strike to the power line and direct lightning strike to the nearby of the power line. We will require only one SPD at the entrance of the facility, only an SPD here. It should be at 10 by 350. And then if your equipment is little bit critical, you can or you may have an SPD nearby the equipment. That is it. No more SPD is required. So generally, it will be only one SPD for the entire installation in this case. Now, how are SPDs categorized? So, as Gopakumar sir said, there are class B, C, and D, the old names. Right now, it is 1, 2, and 3. So, this Type 1 is tested for 10 by 350. Type 2 is tested for 8 by 20 surge current. And type 3 is tested for a 1.2 by 50 voltage impulse. And it's a combination wave where even 8 by 20 is infected. So we have three types. And these three types shall be used in type 1 shall be used in 0 to 1, type 2 shall be used in 1 to 2, and type 3 shall be used in 2 to 3 zone. So what are these SPDs? So this is how generally an SPD looks like, and all type 1 SPDs are type 1 plus 2. That means they are tested for both type 1 and type 2 application. So you can use it in both these applications. But if you see here, type 1 is tested for a 10 by 350 100 kA lightning impulse. And this type 1 is tested for a 50 kA lightning impulse. And this type 2 is also tested for a 10 by 350 lightning impulse. But its surge current is only 12 kA. Okay. So even type 2 SPDs can become type 1, but it cannot withstand a higher surge current. That is why we say we don't use type 2 SPDs for a type 1 application. Now, how do you install or how do you select an SPD with respect to the power lines? There are two types of connections. One connection, you have your power line and your earth conductor or your PE conductor. This will be installed from each and every power line with respect to earth. So you can see here, there's a SPD connected to PE and with every phase and neutral with respect to PE. Okay, this is called as 4+0 connection. So there are 4 numbers of SPD between line to earth, line neutral to PE. It is line neutral to PE. Connection type 2, you have all the phases which are connected to neutral, and neutral is in turn connected to earth. Okay, so this is called as connection type 2, which is called as 3+1 SPD. And there are 3 numbers of SPD between line to neutral and 1 number of SPD between neutral to PE. Okay. Obviously, both these connection types has its own advantages and disadvantages, which I will just explain. So, for example, connection between line conductors and PE conductors, which is connection type 1, 4+0 connection, is called as common mode protection. We are expecting surges between line and PE. Connection type 2 is called as differential mode connection. It is between phase and neutral to earth. So, as per 60364 standards, protection between line conductor and PE is a mandatory requirement. It is called as impulse withstand and it is mandatory. Okay. Now, protection between line conductors and neutral, that is connection type 2, and neutral is in turn connected with the PE, is called as impulse immunity. And this is a recommended requirement. This doesn't mean that the type 1 protection cannot protect against line to neutral surges. It can. It will just have a little bit bigger voltage, protection voltage. Protection between line and conductors, some people will put every SPD between phases. It is completely optional. So, where most of the surges which we expect in a power line SPD are a common mode, we expect a common mode surge. But that doesn't mean common mode surges are more frequent. Differential mode surges are also frequent for much more critical equipments, because for critical equipments, neutral to line surges are, they cannot withstand a neutral to line surge. Now, what is the disadvantage of having 4+0 or an advantage is that UP is called as voltage protection level, and this UP is between the neutral and the PE. So it is the SPD. It is just within the SPD. Okay. Now, if you take a 3+1 SPD, there are two UPs. That is, one is SPD 123 will have one UP value, and SPD between neutral to PE will have next UP value, which makes it a little bit lesser effective. If you take the total voltage protection level for a 3+1 SPD, it will be higher. And if the manufacturer has not declared the value, standard says you just add these two UP values. And generally it will be double the UP value. So lightning transient in common mode, CT1 is better. And switching surges between line to neutral, CT1 and CT2 is better. Now I've already shown you this in another form in the previous slides. So we have class 1 is 1.5 and class 4 is 6.6 kV. So for example, if the voltage protection level of an SPD is from line to earth is 1.5 kV, for a 4+0 SPD, it is going to be 1.5 kV. If you take a 3+1 SPD, they will declare two voltage protection level values. One is line to neutral, which is 1.5 kV, and neutral to earth, which is also 1.5 kV. So, which makes the SPD, which makes the total voltage protection level as 3 kV, that is from line to earth. Okay. Do remember, line to earth voltage protection level is a mandatory requirement from standards. Now, after this, after the selection of an SPD, we are going to another subject called as installation of an SPD. So basically, how you have to install and what is the wire length of the SPD. For example, just some small calculations. I take a wire of length 1 meter. So, and I assume a value of 1 microhenry inductance per this 1 meter length. And for a first positive impulse, the voltage drop across this wire length is inductance multiplied by di by dt, which makes the value as 20 kV per meter. That means the voltage drop across this line is 20 kV per meter. Okay, di by dt is assumed as 20 k by microsecond, which is given in part 1 of the standard. This is for positive lightning strike. For negative and subsequent, it is 100 k by microsecond and 200 k by microsecond. So you can see here. Now, what happens when you have a longer lead length? We have a subject called as UPF. UPF is the total withstand voltage of that entire installation. So, for example, you have an SPD, you have an SPD UP. This SPD's UP is already defined by the SPD datasheet. But then parallelly, you will have L1, which is the connection lead length 1 and connection lead length 2. Okay. These L1 and L2 together makes UPF. You can see UPF is the voltage drop at L1 plus UP plus voltage drop at L2. Okay. So let me just show you a small calculation. But before that, UW is the voltage protection or impulse withstand of your equipment. That means your equipment, for example, if it is tested, if it is a class 3 equipment and it is a lift, which is a class 3 equipment, it is tested for 4 kV. Okay. So your SPD should be lesser than 4 kV, or this total UPF should be lesser than 4 kV. And generally in standards, we tell it should be 80% of this of the equipment. Now, if I take an connection lead length of 500 mm or 50 centimeter, that means 50 centimeter is the total. L1 plus L2 is 50 centimeter. And UP of the SPD is 1.5 kV. And UPF, I've already told you, it is you have to add all these together. For a level 1 lightning, okay, that is 200 k, and voltage drop at a 500 mm wire length is going to be, for a first positive impulse is going to be 100 kV. First negative impulse is going to be 50 kV and subsequent impulse is going to be 100 kV. Okay, all those calculations you can also refer to part 1 of the standard where they have a beautiful table. So when I calculate the total UPF, it becomes 11.5. Next UPF becomes 51.5, and the subsequent impulse total voltage protection becomes 101.5. This is for level 1. Okay, so it becomes, that's a huge voltage drop across this line. Parallelly, if I consider for a level 4 and 50% of the current, generally for SPDs, we take the LPL level and the 50% of that LPL current to consider the SPDs. We get an voltage drop of 2.5 kV for level first positive impulse. For first negative impulse, we have 12.5 kV and subsequent impulse is 25 kV. So when I add them together, I get 4 kV, 14.5, 14 kV and 26.5 kV. This is 50% of the current in LPL level 4. Okay. Considering a 550 centimeter wire length, that is the total SPD's wire length from the face to the P or earth connection is 50 centimeter. What do standards recommend? Standard recommends this 50%, 0.5 meter requirement, or you do a V-type connection. A V-type or a bus bar mounted connection. So basically the SPD will directly be connected to the panel, the bus bar, or you have a line which will come to the SPD and there's generally there will be a second port through which you can directly connect to the line again. So we call it as a V-type connection. And when you do a V-type connection, we'll have little bit more margin in the downside and we can have a longer earth conductor. Okay. Or you can directly mount the SPDs to the bus bar. There are special SPDs where you can directly mount to the bus bar. Most of the SPD failures in India, or most of the time where equipments are failing and SPD is just sitting simply, is because the lead length is too high. Okay, the equipment will protect the SPDs. So these types of installation is strictly not recommended. You can see here maybe the lead length is more than 2 meters. So that's a separate junction box for SPDs. It should be combined along with the panel. These are truly not recommended, and most of the cases you can find more than 5 meter lead length. Now, backup protection will be explained more in detail by Mr. Vijay. But before I go to that, before I leave my session, I want to explain a very simple topic. For example, every SPD at its end of life, an SPD will fail. Okay. To prevent its failure or to prevent much fire, we provide an backup protection. Generally, it will be a fuse. All SPDs are tested for a fuse. But the problem happens when some people or some manufacturers says that you can use a MPCB to give this backup protection. What happens is, I know the voltage drop at level 1 and L1, length L1, and I know the voltage drop at L2, and I know the voltage protection level of the SPD. But what I don't know is what is the voltage drop at the MPCB or any other circuit breaker. It is an unknown value. So what happens is, generally when you provide MPCB or some other circuit breaker, I cannot guarantee that an SPD will work because the voltage drop at here is unknown. Because there are lot of thermal and magnetic elements inside a circuit breaker, which makes it really hard to define a voltage drop against an impulse. So do consider, and you have to really consider whether you want to use an MPCB for an SPD as a backup protection. So with this, I will end my subject. Let me just stop my sharing. Vijay sir, can you take over for the next subject?
Yeah, thank you, Anandu, for this informative session. Okay, good morning to everyone. So I'll continue from here, from where Mr. Anandu has left. I'll continue the presentation from there. I'll just share my screen. Give me a moment. So I hope my screen is visible and I'll continue. Now, as Mr. Anandu very well said that the backup protection in an SPD is a very important subject and it's also a very confusing subject. A lot of people don't know what exactly they need to use as a backup protection. People are still confused between fuse, MPCBs, MCBs, what they have to use and what rating they have to use. So I'll just go into detail that why exactly we need a backup fuse. So SPDs are most sensitive devices in electrical network. They have response time in nanoseconds. Mostly SPDs are connected between line or neutral or line to earth, depends on the connection type 3 plus 1 or 4 plus 0. So normally, there are two kinds of major components which are used inside an SPD. Either it's an MOV or it's an spark gap, or it can be a GD tube also. In case of MOV, during TOV conditions, temporary over voltage conditions, it may fail and create a short circuit. Similarly, spark gap SPDs may create a short circuit due to follow current. So I'll just show you. See, suppose this is a connection. Okay. In this connection, you see the SPD is connected between line and neutral. And we have a fuse. Let us call this fuse as F1. It is the main incomer of the fuse. Right. So in this case, suppose an SPD fails. This SPD fails. Once it fails, there are two possibilities. It can fail in a short circuit mode or it can fail in an open circuit mode. Once it fails in an open circuit mode, or that means the thermal disconnector inside the SPD disconnects, it becomes an open circuit mode of failure and there is no problem. SPD disconnects itself. Now, condition number two, when SPD fails in a short circuit mode, during that time there will be a short circuit current which flows through the SPD this way from line towards neutral or earth, whatever way SPD is connected. Due to this short circuit current, the energy dissipated is quite high and SPD can catch fire. So we need a backup fuse to ensure that SPD is properly disconnected during the event of SPD failure. Okay, just a moment. Uh, Let me try to. Just a moment. Okay. I hope my screen is visible again. Right.
No, your mail is visible. Can you close it?
Now is it visible?
Yes, you
Yes.
Yes.
can
Okay.
start it.
Okay. Fine. So now there are two conditions. The way fuses can be connected, as I told, why we need a backup fuse, because in case SPD fails in a short circuit mode, need a device which can disconnect the SPD from the current circuit. Now there are two cases. Normally, if we see a manufacturer's catalog, there will be a point written as maximum backup fuse up to X rating. Let's say in this case we have written 125 amps. So when a manufacturer says that maximum backup fuse which can be used in their with their SPD is 125 amps, it means if the incomer rating of the DB where the SPD has been installed is less than 125 amps, that means F1, let's say we call it a F1. If F1 is less than 125 amps, no additional backup fuse is required with respect to protection. That is with respect to protection. No backup fuse is required. Similarly, in the second case where F1 is greater than 125 amps, we need a second backup fuse which is called as F2. We can call it F2. Now the condition, there are two conditions which we have to follow here. First, as the manufacturer has suggested, this F2 cannot be more than 125 amps. Sorry, F2 is required when F1 is more than 125 amps. Second, F2 should always be lesser than or equal to 125 amps. So this is how these are the two important things we have to take care while selecting an backup fuse. First, backup fuse, or we call it F2, shall not be more than the primary fuse, the primary incomer, which we call F1. And second, F2's rating shall be maximum up to what the manufacturer has claimed. Okay. Now, in this case one, another thing we have to we see is once this SPD fails with a short circuit, this F1 will trip. Once F1 trips or F1 the fuse blows off, the supply to the equipment gets disconnected. Whereas in the case number 2, once the SPD fails, only F2 will blow and F1 will will be in open mode. So we get continuity of protection. So there are two things. One is priority to continuity of supply. Second is priority to continuity of protection. In case number 1, we are getting a priority to continuity of supply. If you see this case, in case number 1, when SPD fails, F1 blows out. That means supply is cut off. So in this case, whenever SPD is blown or failed, the supply to equipment is cut off. That means we get a continuity of protection. That equipment is always protected. Once the SPD fails, the protection goes, equipment supply also disconnects. Whereas in second case, whenever SPD fails, only F2 blows. That means the supply continues to the equipment. So we get continuity of supply in case number 2. So if we need priority to continuity of supply, we need to use a backup fuse irrespective of the incomer rating. So this is what I was explaining, priority to continuity of protection and priority to continuity of supply. Now, where the priority to continuity of supply is required, so there are applications like data centers or maybe some process industries where they always want their plant or the conveyor belt or any equipment to run every time. So they don't want any disconnection in supply. So these places we have to ensure that we are using a backup fuse F2 irrespective of the incomer rating. So we get the continuity of the supply. Whereas there are some condition places where protection is utmost important. In some military cases, that data is so sensitive that they cannot let it let it be unprotected. In that case, we have to ensure that priority of continuity of protection is maintained. Now, what if we want both? In that case, there are SPDs which comes with a backup protection device. You can see in our screen. These SPDs have a redundant SPD. That means once the primary MOV fails, so the primary protective device fails, immediately the secondary protective device will be under operation. So your equipment will always be protected and supply will be continued to your equipment. The advantage of these particular SPDs are once these SPDs of the primary device fails, you see an indication given in this SPD which is green in color. Once the primary device fails, this green color will change to yellow and then you can keep spare with you. Once the yellow fails to red, immediately you can change the spare. So with this use of this particular SPD, you can get continuity of supply as well as continuity of protection. Now, even after so much discussion, people still are confused about what rating of fuse we need to use. And another problem with fuses is they are bulky in nature. For example, there is an incomer rating of let's say 3200 amps or maybe 4000 amps. So at times you may need a fuse of up to 630 amps or 315 amps or 400 amps. So in that case, the size of the fuse will be very high. Plus, fuses increases the complexity in the circuit. you need to do the wiring. Sometimes the fuses blow up, but SPDs are still working properly. And again, these are parallel connected devices. We have to check physically whether the fuse is working or it has been blown up. In that case, SPD gets disconnected because of the fuse blown. Now, to avoid all these confusions and complexity, there is another option. What we can do is we can use SPDs which have integrated fuse. So these can be type 1 and type 2 SPDs. Again, these SPDs are also tested with the standard IEC 61643 part 11 2011. Again, one more thing I would like to add here is the same IEC 61643 part 11 2011 has been adopted by Indian standard IS also as IS 16463 part 11 2016. So the component used in this particular SPDs are phase GDT, which is a patented technology by ACAP. So these SPDs have safe behavior under lighting conditions. It has an inbuilt backup fuse. So even if you have an incomer rating of 4000 amp, you don't need a backup fuse. So because now the backup fuse is reduced, the cables connecting the backup fuse will also be reduced, and you get a better protection levels. So these SPDs are leakage current free, shorter connection lines, of course, because of the new use of backup fuse. It's again a reliable disconnection device. You don't have to really rely on a second device. SPD has inbuilt fuse, so the coordination is better. Impulse current up to 25 kiloampere, and most importantly, the short circuit current it can provide up to 100 kiloamperes. So now actually the short circuit current is one of the important parameters while choosing an SPD. Normally once we choose an SPD, uh, first thing we say is we need a 50 kiloampere surge protection device. Now with respect to SPDs, there are multiple current parameters. There are impulse current, there are nominal discharge current, there can be maximum discharge current, and there can be short circuit current rating, ISCCR. We'll discuss about the impulse current also. First, the short circuit current rating as per IEC 60364 part 5 part 53, it says that short circuit current rating of an SPD shall not be lesser than the expected fault current at the connection point. That means if we are installing an SPD in the main incomer panel, let's say a 4000 ampere panel, and with a fault current rating of 65 kiloampere, those locations, SPDs with or without backup fuse shall provide a short circuit rating of not less than 65 kiloampere. Now, unfortunately, most SPDs available in Indian market have a short circuit current rating of lesser than 50 kiloampere. So this can create a serious fire hazard during the SPD failure. So while selecting the SPD, of course, we have to select whether we need a type 1 SPD or type 2 SPD. We have to see the voltage protection level. We have to see the location of the SPD. But in addition to all these parameters with respect to safety, we have to see the short circuit current rating of the SPD. It is a very important parameter. So these integrated fuse SPDs have short circuit rating up to 100 kiloampere without any additional backup fuse. So similar to type 1, we have also type 2 SPDs with integrated backup fuse. They also have a short circuit rating of 100 kiloamperes, especially in the places in the DBs where the space is very less. The space is there is a crunch of space there. We can use this kind of SPDs called as Protect T2F series SPDs. Now, temporary overvoltage conditions. Now, earlier also I have used this word TOV while telling about the MOV failures. Now, as Mr. Anandu has told, voltage protection level. So, voltage protection level of an SPD is the voltage at which an SPD starts to operate, or at a protection at which an SPD operates or reacts. Now, generally, as Anandu told, that voltage protection level of a 4 plus 0 connection SPD is around 1.5 kV in general, whereas voltage protection level in a 3 plus 1 SPD is generally 1.5 plus 1.5 around 3 kV. Now that means an SPD will operate somewhere near to 1.5 or 3 kilovolts. Whenever there is a surge of 1.5 or 3 kilovolts, SPD will operate. Now, normally MCOV, the maximum continuous operating voltage of an SPD, is generally in between 275 to 320 volts. That means continuously we can give a voltage of 275 to 320 volt. Now imagine a condition where there is a neutral cut. During that condition, sometimes the voltage between line and neutral can go up to 400 volt. Now, what will happen in this condition? Now, this 400 volt is lesser than the voltage protection level. That means SPD will not operate at 400 volt, but it is higher than the maximum continuous voltage we can give across the SPD, which is around 300 volt. Now we have a 100 volt across the SPD. Now because of this actually condition is called as temporary over voltage condition. This condition can actually fail an SPD, and I will tell you I will just show you a small video what can happen if the SPD is stressed under TOV conditions. So this is a video from one of the places in Karnataka. So, so this particular SPD was continuously stressed due to TOV conditions, and because of this TOV condition, this extra 100 or 140 volt, the SPD blasted. So this was the condition of the SPD once it has failed. Now, because of this problem, standard introduced IC introduced a test called TOV test. So every SPD has to be tested with a TOV condition, or you can say that every SPD has to be tested with temporary overvolt for 120 minutes. For 2 hours, SPD is given 440 volt across its terminals. Now, standard said that there are two results which are acceptable. One SPD can withstand 440 volts for 120 minutes without any change in the parameters. That is acceptable, of course. The second acceptable result is SPDs are allowed to fail. They are allowed to fail, but they are not allowed to create fire. They are not allowed to blast. So the second acceptable condition is fail-safe conditions. But unfortunately, uh, in India, most of the manufacturers are not actually educating client with this particular TOV parameter. Even sometimes they are not even aware of this TOV parameters. Our National Building Code of India 2016 clearly states that SPD shall have TOV immunity. They should all have SPD which are sold in India shall have TOV immunity. Additionally, NBC says that all the SPDs in India which are sold in India shall have indications line to neutral or line to earth in case of 4+0 connection, as well as neutral to earth, because neutral to earth plug is also as important as line to neutral plugs. So all SPDs shall be pluggable and shall have remote signaling or failure indication in all the plugs. So these are the SPDs which comes with TOV immunity. So we have two different models. Just for example, just to show, I am showing this particular model. First model is Protect T1H. The same model is actually now been upgraded to TSD T1H, which comes with a Cape brand. Okay, so the basic difference between T1H and T1 series SPD is T1 is H have TOV immunity. That means it is tested with TOV 120 minutes withstand, whereas T1 is an SPD tested with TOV 120 minutes fail safe. Now one more thing, actually a lot of people sometimes gets confused is how to select an SPD based on the rating. Now, there are two kinds of SPDs, class 1 SPDs and class 2 SPDs, as Mr. Anandu told. Class 1 and class 2 SPDs are generally two kinds of power SPDs used. The basic difference between class 1 and class 2 SPDs is the impulse current rating. That class 1 SPD shall have impulse current testing, that means a lightning current testing, or class 2 SPDs generally do not require any lightning current withstanding or lightning current testing. Now, but the point is, how do we ensure that what is the minimum rating of lightning current in a class 1 SPD? Class 2 SPD, you can say it is a zero, you can call it a zero value. Okay, you don't need lightning impulse current. But class 1 SPD, what is the minimum impulse current rating? Because if I put a 2 kiloampere of impulse current in an SPD, whether it can be called as class 1 SPD, whether I can put 3 kiloampere, 4 kiloampere, what is the minimum rating of impulse current required to call an SPD as class 1 SPD? So now this is it is believed as per standard, whenever there is a lightning strike, 50% of the lightning energy is being dissipated into the ground. Remaining 50% is again diverted back to our building through the various sources, various metal services coming inside the building. Now I'll just because we have some what lesser time, I'll just jump to the chart. Okay, so this is the chart. So in level, there are four kinds of lightning protection level: level 1, 2, 3, and 4. So level 1 has a maximum lightning current of 200 kiloamperes, whereas level 3 and level 4 has a lightning current of around 100 kiloamperes. Now in this 200 kiloamperes, 50% lightning energy comes back into our building. That means that is 100 kiloampere. Whereas in level 3 and level 4, we expect around 50 kiloampere of lightning current to come into our building. Based on that, if the building comes in level 1 and level 2, the minimum impulse current rating required in NSPD to be called as class 1 SPD is 25 kiloampere. Whereas in level 3 and level 4, minimum lightning current required is called as is 12.5 kiloampere. Why I have raised this point is because it is a little bit unfortunate that our Indian clients are being confused in what is class 1 SPD, what is class 1 plus 2 SPD, and what is class 2 SPDs. So I would like to clear a myth here is every class 1 SPD in the world is actually a class 1 plus 2 SPD, because generally class 1 SPD waveform is 10 by 350 microsecond waveform. That means a impulse current in an impulse current uh, it reaches to its peak value in 10 microsecond and reaches to half of its crest value in next 350 microsecond. So total time duration is around 360 microsecond. Whereas in switching surge, it is around 28 microsecond. It is called as 8 by 20 microsecond surge. So energy in a lightning surge is much more than a switching surge. In a layman term, we can say that lightning surge is a bigger surge when compared to switching surge, just in a layman term. So an SPD which can withstand a bigger surge automatically will withstand a smaller surge. So every class 1 SPD by default will withstand switching surge also. So every class 1 SPD is also class 1 plus 2 SPDs. Now the question comes, then why there are three kinds of different models in market? Class 1 plus 2 and class 2. Because now prior to NBC 2016, the minimum value of impulse current was not established in 61643. So what happened was people created three different models: class 2 SPDs with zero impulse current, class 1 SPDs with probably 25 or 12.5 kiloampere impulse current, and in between they introduced one more model with maybe 4, 5, 6 kiloampere impulse current. That was actually as per standard a type 2 SPD only. But as a part of probably a marketing gimmick, the third SPD was introduced with a separate category as B plus C. But once the NBC 2016 came, they made it very clear for any SPD to be called as class 1 SPD, minimum impulse current of 12.5 kA line to neutral or line to earth is required. In case of 3 plus 1 connection, neutral to earth shall have minimum impulse current of 50 kA minimum. Of course, if it is in level 1 or level 2, it should have minimum 175 kA impulse current. So this parameter was very important actually to clear, because a lot of people have this question to me: what is the difference between class 1 and class 1 plus 2, or more commonly known as class B and class B plus C? So this is the difference. Every class B SPD is typically a class B plus C SPD, and for any SPD to be called as class B plus C, minimum impulse current shall be 12.5 kiloampere. So whatever questions you have, please you can have these questions in Q&A box. Now we have discussed about voltage protection level, wire length, and backup fuse. These are the problem we have discussed, especially about wire length. Now, how do we solve a problem? Now, generally, there are two kinds of SPDs available. First is dendril mounted SPDs, second is bus bar mounted SPDs, or we call it strike swap series. Now, these are a very high quality SPDs with a very high energy MOVs used. These SPDs are warranted for 10 years, have a lifespan of 20 plus years. In India, generally they can withstand up to 30-35 years. Now, during the failure, they have a if they fail, they fail in a very safe manner. They have overall very better protection. We'll discuss further in the slides. These are TOV immune SPDs. These are tested with IC as well as UL. So we have these are in the market for more than 20-25 years. We have sold more than around now we have sold more than 25 million units and practically has zero failure. So this is the internal configuration of these SPDs. These SPDs have aluminum cases. Since these are aluminum casing, strong aluminum housing, during the failure it does not create give any fuel to burn. So there is no burning during the failure. So it has a pressure of around 1500 pounds, which gives a very high low resistance and high conductivity. It uses a single metal oxide varistor which has a maximum discharge current up to 200 kiloamperes with a single metal oxide varistor. So there are multiple models, strikes of 30, 40 and 80 with have multiple impulse current and maximum discharge current like 60 kiloamperes for 30, 140 kiloamperes for 40 and 200 kiloamperes for strikes of 80. We have multiple voltage ranges 60, 120 to 40 to 77 volt. So we have various model A, B, C, D, E, F and G in strikes of series. Then we have strikes of for DC series also, strikes of 35 series. So these are the again we have for all our SPDs strikes of 30, 40 and 80, all SPDs we have tested with 2000 back to back surges, switching surges of 10 kiloampere each. So for SPD to have 2000 to withstand 2000 surges, it should have a very good quality of protective component. So you can see the energy handling capacity of these SPDs. So these are the general life cycle of an SPD. So one life cycle test actually reflects around 20 years in standard lightning environment. Strikes of 40 was tested to a total of 10 lifetime cycle. That means a strikes of 40 in a general lightning environment like India, we can call it a general lightning environment, can have a life of around 200 years. So of course nobody is going to wait for 200 years and nobody and the panel in which the SPD is going to be installed will not actually work for 200 years. But at least without any doubt SPD will be there for at least 30-35 years, which is actually the life of the panel. So a strikes of 40 series SPDs, which we call it has a impulse current of rating of 12.5 K, actually has been tested with a impulse current of 200 K, which is quite high. Like practically it is almost impossible for an SPD to have this high rating of impulse current. So this is a lead through voltage graph of an two SPDs. One is dendril mounted SPD, second is the strikes of series SPDs. As you can clearly see, for a dendril mounted SPDs, the lead through voltage increases drastically or exponentially once the surge current increases. Whereas in the strikes of series SPD, the surge currents are the lead through voltage is almost constant, whatever the surge current is. Because this is how normal strikes of SPDs are connected in the bus bar, whereas dendril SPDs are connected with the external fuse. These are some of the installation photos of the strikes of series SPDs. So whatever questions you have regarding these SPDs, please drop in the Q&A box. Now this was about power circuit. So we'll just have a brief discussion about communication or signal SPDs also, because they are also equally important when compared to the power SPDs. So we have somewhat lesser time. So generally the signals can be of two type, differential mode, the signal communication can be of two type, differential mode communication or common mode communication. Suppose there are two wires, so wire A and wire B carrying signal. If the the communication is happening between both the wires, it is called as differential mode communication. If the communication happening between signal wire A or the common wire, it is called as common mode communication. SPD should provide protection against both the modes. Now, this is what can happen to a transistor or data circuits when they are left unprotected. For example, Mr. Gordon Moore, the founder of Intel, once said that every 2 years, number of IC circuits in a transistor gets doubled. Uh, so every 2 years, number of IC circuits gets doubled. So once the number of circuits gets doubled, the space between them gets lesser, the insulation becomes lower, and the chances of failure becomes very high. So this is an example. In 1915 and 60s, a normal component could withstand up to 10 joules of energy. Whereas now in 2020s, now we are also in around, okay, we are in 2025, mid of 2020s. This has reduced drastically. Single component, the VLSI component can withstand sometimes somewhere in between 10 to the minus 8 joules of energy. So there are generally three components used inside an communication SPD: gas discharge tube, metal oxide varistors, and diodes, sometimes also called as transorbs. So GDTs have very high energy handling capacity, mid or low lead through voltage, and very poor follow current capability control. Metal oxide varistor has decent energy handling capacity, low lead through voltage, and low follow current. Diodes have very low energy handling capacity, low residual voltage, and very low follow current. This is called as energy coordination. This is small graph which is showed an energy coordination. And normal SPDs have three stage protection: stage 1, stage 2, and stage 3. Stage 1 we are protecting through GDT. Stage 2 we are protecting through an metal oxide varistor, whereas stage 3 we are providing diodes. Stage 3 diodes are the fastest operating devices, whereas stage 2 MOVs have somewhat lesser operating time, whereas higher energy handling capacities, while diodes have highest voltage protection level but highest energy handling capacity also. So once there is a surge, immediately, let's say there is a surge, our diodes operate, stage 3 our diode operates. Let's say diodes have operated at 600 volt. It's just an example. Diode has a voltage protection level of 600 volt, whereas MOV has a voltage protection level of 800 volt. Now, once the surge has come, diode immediately operated at 600 volt. So diode will clamp the voltage at 600 volt, but to ensure that we have to we have to ensure that MOVs also need to get operated. Now MOVs has higher voltage protection level. In this case, the example which I have taken, MOV has a voltage protection level around 200 volt more than diodes. So how do we ensure that MOVs are also operating on time? So we provide another component, an impedance. It can be resistor or inductor in between stage 2 and stage 3 in such a way that there is a such voltage drop across this impedance that it ensures that MOV operates. So in this case, 600 volt diode was used, MOV was 800 volt. So we ensure a impedance of such a rating that which can make a voltage drop of 200 volt across it, so that in stage 2 MOV also operates. Similarly, in between stage 2 and stage 3 also we put a component which ensures that there is a voltage drop across it, which makes GDT also operates. So in below you see the graph of the energy handling capacity. Highest GDT have the highest, MOV somewhat lesser, and diode very less, whereas response time, diodes have very fast response time, MOV somewhat better, somewhat slower, GT slowest when compared to diode. Now, in general, in the power circuit also, generally the acceptable response time is up to 100 nanoseconds. You can find SPDs with various response time from 1 to 100 nanosecond. 1 is the best quality. The Trisob series SPDs have response time of 1 nanosecond. 25 is good quality, and 100 nanosecond is also an acceptable result. So these are the various stage energy coordination in an SPD. You see the diode, MOV, and the GDT. They clamp the voltage at different levels. The similar example with a circuit, you see first stage one is GDT, then we have a resistor and inductor in parallel, then we have stage 2 MOV and stage 3 diodes. Okay, this is a normal example of a CCTV circuit where you need an SPD to protect your distribution panel, your monitor, control panel, and also your camera. So, so this was somewhat about the power and distribution SPDs. Now this is few details are of the SPDs which we provide in the market. Now just to avoid the confusion, the SPD which are shown in the figure have a brand called Recap. Recap is basically a German company which have manufacturing across Europe and USA. Now all these SPDs has been upgraded in India and comes with the name of Cape Electric and a TSD series SPDs. So we have multiple like first series is Protect T1HS series, now called as TSD T1HS series. These SPDs are TOV immune SPDs, TOV withstand 120-minute SPDs with a high impulse rating of 25 kA per pole between line and neutral. And in case of 3+1 connection, it has a response impulse current of 100 kA. It has a maximum discharge current of 65 kA per pole line to neutral and 130 kA neutral to earth. Again, one more advantage of these SPDs are these all SPDs are pluggable in nature. What do you mean by pluggability? So if you see, for each phase we have a separate plug. Now, for example, in future, let's say after 4 or 5 years, due to some condition, our phase have failed. If SPDs are not pluggable, even failure of one phase will you'll have to change the complete SPD, complete block. Here, in the pluggable SPDs, once R phase is failed, you can only replace R phase. You don't need to replace complete SPDs. Now these are second series SPDs called as T1H series. It can be Protec or TSD. These are similar to T1HS SPDs. These are TOV withstand SPDs, but has an impulse current rating of 12.5 kA line to neutral and 50 kA neutral to earth. Now there is one more advantage these SPDs have, that these SPDs are leakage current free SPDs. What do you mean by leakage current? Leakage current means sometime metal oxide varistor based SPDs can have a problem of leakage current. So even if there is no surge, there is a small leakage current which flows through the SPD and which reduces the life of an SPD. Now because these SPDs are leakage current free SPDs, the life is generally double when compared to the normal SPDs. So these are integrated fuse SPDs class 1+2, which we have earlier discussed in the slides. These are class 1 SPDs which are TOV safe fail. As earlier I have told, the standard has given two options for SPD. SPD can be TOV withstand or SPD can be TOV safe fail. TOV withstand SPDs were T1 S series SPDs and HS series SPDs, which I have told just now. Now we have TOV safe fail SPDs called as T1 SPDs. These also have an impulse current of 12.5 kA, which is the minimum requirement as per National Building Code of India 2016. Again, I am repeating this point because there are a lot of SPDs in the Indian market which have an impulse current of 5, 6, 7, 2, 3 kiloamperes, and they call themselves as class 1+2 SPDs. As per Indian standards, strictly they are not 1+2 SPDs. They are strictly type 2 SPDs. Anything less than 12.5 K means a type 2 SPD. So these are class 2 SPDs with TOB withstand parameters. Again, these are pluggable and high short circuit ratings. Class 2 SPDs with TOV safe fill parameters. Then we have class 2 SPDs again. And then also in class 2 we have integrated fuse SPDs. This was about power SPDs. Then we have data SPDs. These are signal SPDs for RS-485 communication system. This comes in two wire as well as 4-wire communication systems. These are SPDs for Ethernet devices for camera and especially for network switches in the data centers and all. Wherever industries I have been for any audit or any discussion, one thing I have seen is CCTV and network switch have always failed. So this is now has become a mandatory requirement for a communication system. And while selecting this Ethernet SPDs, you can see the internal diagram of this Ethernet SPD. We have provided four protection components, four set of protection component, four numbers of JTs and diodes. So unfortunately, again in India, to reduce price, people will give one number of components and make it parallel with all the protection lines to reduce cost. But actually, it reduces the reliability and efficiency of an SPD. So these are the surge counters, which sometimes, because SPDs are parallel connected device, and they really do not trip, just like MCBs. Whenever there is a fault current, MCB trips, whereas nothing like that happens to SPD. SPD during the surge, SPD will operate, and after surge it will regain its original position. Then how do you know that there was a surge? So you can install an counter next to an SPD, which will give you date and time of the event. It will log up to 999 events, and then it can be reset. So that was it from my side. I tried to make it very crisp and give maximum possible information. Please share your questions or drop your questions in the Q&A box. I'll stop my screen now. If you have any doubts, otherwise you can just contact me on the given number also. My number is there on the screen. My number and my email ID is there on the screen. If you have any technical doubt, you can please drop an email or just give me a call. Thank you.
Okay. Can we take care of the Q&A questions?
Yeah, go ahead. I think you can
Yes.
start with that. Yeah.
Okay. So, Vijay sir, I'll be reading out the Q&A question, and we can take care
Yes.
of the Q&A questions.
Yes.
Okay.
One by one we can do it.
Now, first question, we see power fluctuation from EB source as well as during auto changeover. Second. Yeah. As well as during auto changeover from EB to DG or vice versa. In few other cases, we have seen fire alarm panel 230 volt and other equipments got damaged. Please suggest a solution which SPD can be used and where we need to put these. This is due to fluctuation in EB source. It is not related to our SPDs.
No, I believe here there is a switching surges during changeover from EB to DG. It is not during the continuous EB supply. Once they are switching from EB to DG, there is a switching.
Yes,
That
it is
kind
from
that time there is a switching surge.
auto changeover from EB to
Yes.
DG. Yes.
Yes. So probably a type 2 SPD or type 3 SPD will solve the problem.
Yes. Generally, a type 2 SPD is enough. Now, next one. Please let us know the parameters to consider backup protection. Because SPD makes dead short circuit during surge. Okay, we have already answered this in the PPT.
Yes.
For backup
Yes.
protection, we use a fuse and it depends on the manufacturer. For example, we provide 315 amps. We have tested with 315 amps GG fuse. And it depends on the manufacturer. You have to open the data sheet and decide whether you want to go with priority to supply or protection. Okay, next one, a facing case facing an issue of damaged computer, motherboards, and other electronic devices came through. The SPD protection box is just like what we have seen in the photos at the main incomer side. UPS is present at the load side, and the load is electronic. What do you suggest? Basically, from what I can understand, the SPD is not it's not put in the panel board, and it is installed separately from the panel board, and there is a huge lead length. So, and you have said that there is a there are damaged computers and electronic devices. This is a typical example of what happens when a lead length is really high. So what you have to do is very simple. You have to either install an SPD closer to the equipment, or you need to install an SPD at the inside the panel board. That's the only two options. And the lead length must be as short as possible. Next question, I think Vijay sir can take. Are there any
One second.
recommendations that says how often SPDs should be replaced? Of course, after damage, but how long does SPD work correctly?
Actually, this nobody can actually answer precisely, because so normally once we give an SPD, we test an SPD with, let's say, 25 number of surges with 20 kilo ampere each. But the problem is, once we test an SPD, what we do is we give a surge through the SPD and then it is allowed to cool down. Whereas in practicality, in the real life condition, we don't know the magnitude of the surge and we don't know the frequency of the surge. Sometimes there can be 10 back-to-back surges and SPD can fail immediately after 10 surges. Sometimes an SPD can withstand even 30, 40, 50 surges. With my experience, I saw we had installed an SPD along with a counter in one of the site in Goa. So once the SPD failed, the reading in the counter was around 38, 39. So we can say in general SPD can withstand around 40 surges, but again nobody can say it absolutely clearly that how many times it will work, how many years it will work. Once it fails, you can the indication will change from green to red, and you can change it, sir.
Okay. In
Also, I
case of
request people to drop questions in the Q&A box also, because I see a lot of questions in the chat also.
we will not be taking most of the questions in the
Yeah,
chat box.
so
Q&A,
yes,
will be
yes.
taking it in the Q&A. In case of integrated fuse, is there a mechanism to understand the blowing of fuse? Basically, in this, the fuse, the thermal characteristics of this fuse is coordinated with the element, the protective element inside the SPD. Okay. So you know that after a certain current, this element gets heated up. That is how the fuse blows up. This thermal characteristics and the MOV or GDTs or PGDTs thermal characteristics are interrelated. So when it becomes hot, this knows how much current has passed and it is stripped. Okay. So we don't need to be worried about how it is stripped because it is already tested as per the standards. Okay. They have installed class 1, 2, and 3 SPD at the same place in a separate panel box. Vijay sir, can you take this?
No, actually, they have installed class 1, 2, 3 SPD at same place in the separate panel box. That means what I understood is, just before an equipment, they've installed a class 1 SPD, class 2 SPD, and class 3 SPD separately for the same equipment, if I am not wrong.
The
So,
continuation of the previous question from the same participant. Continuation
yes.
of the. Yeah.
Yeah, so basically near to the equipment, like we have to define the location of the SPD. Class 1 SPD shall be installed in the first panel in the building where the cables are coming from outside. Class 2 SPDs are for the distribution boards, and class 3 SPDs are should be installed very near to the equipment. If just before the equipment you have installed a class 1 SPDs, for the same equipment you may not need to install a class 2 SPD.
Vijay, I will add here. So here the first question and the second question, what is understood is, in order to protect electronics, class 1, class 2, class 3, or maybe one SPD tested for all the parameters are installed in a separate box and connected to the panel. So once when you install the SPD in a separate box, naturally the line length will be more. Once when the line length is more, the SPD is a dummy. It won't work during surges because of the long line length. Ultimately, your electronics continues failure. So installing SPDs in separate box near to the distribution board is not a good practice. Continue, please.
Okay.
Okay. So
Third one. Can I use backup fuse in earth instead of placing fuse in line in the face or neutral to save money?
So the answer is no. Because actually, what I can understand from this question is they are talking about 3+1 configuration. So that neutral to earth, if they put one fuse, whether it is possible? No, it is not possible. First of all, because there's a possibility of SPD can be of 4+0 configuration. है ना? And generally, the backup fuses are used for all three lines. For neutral to earth, backup fuse is not required.
Yes. Now,
But this
usually
question
SPD
is quite
connection,
interesting. This
yes,
question is quite interesting. How can I use backup fuse instead of line and neutral on the earth line? Impossible.
yes. Okay, next question. Usually, SPD's connecting lead length is mentioned in catalog, but when we coordinate the backup protection and protection lead, we may have to we may have the freedom to connect extra length for SPD to the nearest equipotential bonding point. So he's saying that SPD's connection lead length is mentioned in the catalogs, and but we have to coordinate the backup protection. We have the freedom. Okay, I think this is a statement. Let us go to the next question. Okay, what should be the connecting wire size and how to select? Very simple. Open your data sheet of the SPD manufacturer. He will specify the what are the sizes to be used to connect your SPDs. Okay, can ohmic values be used to indicate the lead length, such as the cable resistance or materials like aluminum or copper? Sorry, ohmic resistance cannot be used because we are talking about inductance and it majorly depends on the line length. And sorry, ohmic resistance cannot be used because during an impulse, it's the inductance which plays a much major role instead of the resistance part. MCOV 275 volt is recommended in India if the component voltage level is 230 to 240 because when it comes to supply voltages India, they vary slightly due to fluctuation and losses in the grid. So he's
Actually,
asking us to comment on this
I
part.
will answer this question. Actually, sir, generally use MCOV values are in between 275 to 320 volts in India, whatever the speed is available. Now, technically, MCOV should be as high as possible. But practically, MCOVs and voltage protection levels are actually interconnected. Once you increase MCOV of an SPD, voltage protection level also increases. So, as per our National Building Code of India, the maximum allowed voltage protection level in for a 230 volt system or 240 volt system is 1.5 kV. So, keeping voltage protection level not more than 1.5 kV, whatever maximum MCOV you get is the best possible value. It can be 275, 300, 320, and if you make a very good SPD, even it can be 400 volt, provided it should not cross 1.5 kV voltage protection level because these both are interconnected. Once you increase voltage MOV, UP will also increase. So if you can make
I think
MCOV of 300 volt and give voltage protection of 1.5 kV, it is better.
Okay.
This is a question which is experienced during 1995, 97, 2000s. So initial days we were supplying SPDs with MCOV 275 volt. But due to the temporary over voltages existed from the grid, most of the time SPDs were catching fire. Then the MCOV, a new model has been made specifically for India with MCOV 280 volt, which is then increased to 290 volt, then to 320 volt. So ideally, MOV based SPD with MCOV 300 to 320 is good because less than that is always a risk because the SPD may fail due to temporary over voltage. Now the challenge is if the MCOV is increased, the voltage protection level also substantially increases. But then it depends upon the MOV manufacturer. There are different kind of MOVs. MOVs can be manufactured with different methods. So it is a high quality MOV can probably withstand the 300, 320 volt MCOV and limit the protection level less than maybe 1.2, 1.5 kV, but it will be expensive. So this is just to add. You can continue.
What type of SPD would you suggest for? Second, I just lost the question. Okay, would you suggest for residents having home automation, VRF inverter based air conditioning, also limited space for DB because builder do not provide. So he's asking what type of SPD do we suggest for a
So
home?
for a bungalow or individual standalone homes or buildings, you can have a class 1+2 SPD near to your incomer panel.
Okay.
Uh, because for the flats, you may have a type 2 SPDs in your DB. Mostly DBs have 8 module boxes, and up to 6 modules are already occupied by maybe RCBUs or something. So they only get a space of 2 modules. So in the market, there are compact series SPDs available, which takes half the size. So those are very useful for these kind of applications.
Okay. So next one, is there any site level testing to ensure that SPDs are good?
So SPD testers are available. If you can buy them, or you can ask other companies. They can go and come to your plant or building or wherever and test the SPDs for you. There are SPDs testers, universal SPD testers available in the market.
Do we have any specific SPDs for CAN bus communication?
I have answered that. It is Ethernet
Okay.
SPD is normally Ethernet or RS-45 is normally used for CAN bus. So we have, I think,
Okay,
answered
okay,
that during the presentation.
okay. For a simple administration in charge of a company, what are your says on SPD provisions to them? I mean, how can this know-how of SPD to be convinced to them?
Actually,
And
SPDs, just like MCBs, are an insurance to electrical circuit. MCBs do not really play part in any the transmission lines or anything. MCBs comes into play when there is a fault. Where similarly, SPD will come into play when there is a surge. If by installing, let's say 20,000 SPD, you are saving your 20 lakhs equipment or machinery, it is worth installing.
okay. Now, is there any SPDs available for DC circuits? Yes, there are SPDs available for DC circuits. In fact, we also have SPDs available for DC circuits. For EV chargers especially, there will be an SPD standard which will be coming out pretty soon, mainly for DC applications. Yes, there are SPDs available for DC circuits. Why connection type 1 is better? We have already answered this with respect to voltage protection level. Basically, the voltage protection level in type 1 connection is much more shorter. In type 2, you will have voltage protection level. You have to add both the line to neutral voltage protection level and neutral to earth. So it makes it, for example, 3 kV, where in normal type 1 connection, it would be 1.5 kV. Okay, what are
Yes.
modular SPDs? Is there any difference in parameters for conventional and modular SPDs? Vijay sir?
I believe when we are talking about modular SPDs, it means pluggable SPDs.
Yes.
Right. So pluggable SPDs, the advantage is if the failure of R phase, you can only replace R phase plug. You don't really have to replace the complete SPD. Whereas earlier, few years back, or still few people have an SPD which comes as a single block. So those single block SPDs, you need to replace complete SPD due to the, even if only one phase has failed.
Not only that, during insulation resistance test, you need to unplug the SPD. If you have a
Yes.
complete SPD, it is very difficult.
No. For battery energy storage system and data center, what additional consideration to be taken for SPD selection? Okay. Now, if I am going to use my SPD for a DC system where there is battery energy storage system, I should not use any PV SPD because the PV SPDs, the surge, the the overcurrent or the short circuit current it is tested is much lower. Okay. So when you use a PV SPD for a DC application, the PV SPD will burn. So for a DC application, you must use a DC SPD. Okay. And when you take data centers into consideration, you will need to provide SPDs, even type 3 SPDs, which is closer to the data racks. Okay. Is there SPDs for sensor cable, which is used in motion weighbridge in railways? Ac- Yes, sir, Vijay, sir.
Generally, for this weighbridge, this load cells, the sensor cable has RS 485 communication. So it can be 4-wire or 2-wire communication. Based on that, we can select SPDs, which I had shown during the end of my presentation for 2-wire and 4-wire SPDs called Red-Hat SLS series SPDs.
Okay. What question? Does these SPDs are designed and manufactured considering short circuit withstand capabilities? Yes, they are
Yes.
manufactured with the short circuit withstand capabilities. You can find
Before
it in the
selecting an SPD, you should always ask the ISCCR of the SPD. Even sometimes the manufacturers don't mention in it their catalog, but it is we have to ask with respect to safety. Because for example, you are using an SPD of ISCCR 10 kiloampere in a place where fault current is 36 kiloampere. So once the SPD fails, there is a strong possibility that it can create a fire hazard. So you should definitely ensure the short circuit rating of the SPD is proper before installing an SPD.
Okay. In case of multiple incomers, grid DG solar BESS, should SPDs be placed on each incomer separately or only on the common bus? Okay, this is not an answer which we can easily explain because it depends on where they are stored. For example, if it is a solar, we will need to provide a solar SPD because there will be an inverter to protect the inverter and the equipments. If there is a grid, we will need to provide a separate SPD for the supply. And BESS, where it depends on where it is stored. If it is stored inside the building, generally we do not need an SPD. Again, this depends on site study and risk assessment to mention where an SPD should be placed in such a location. What are the key consideration when selecting and installing a surge protected device for an emergency fire emergency alarm panel to ensure compliance with safety standards and uninterrupted system functionality?
Generally, for a emergency alarm panel, we need to install the Type 2 SPD. So we can have a TOV immune Type 2 SPDs to ensure that you get a longer life in an SPD because those are leakage current free SPDs.
Does SPD provide protection for transients below peak level, zero crossing, etc., as they damage electronics, cause hanging of PLCs? Vijay sir?
Okay. So generally SPDs provides protection for peak levels only. Zero crossover during zero crossing, the voltage will in a AC side during zero crossing, the voltage will be at a zero level. So
Yes.
again, one more thing is the cycle of a surge is very small. Like we have to understand there is a difference between over voltage and surge. Surge can come at any point. It can come at peak or it can come at zero crossing. So whenever the surge is coming, irrespective of the position during the cycle, SPD will operate actually.
Okay. We have SPDs installed in the incomer in a separate box with lead length of 1.5 meter. However, we are still facing electronic card failures in our system. Very simple. You should not install it in a separate box outside the panel. It should be installed inside the panel and the lead length should be, total lead length should be less than 0.5 meter. Only then
And
your SPD will operate perfectly.
one more thing here for this card, for card, we have to ensure that the communication line is also protected, not only power line, because this
Yes,
card will have some signal lines also coming into the card.
You
yes,
see,
yes,
mere
yeah.
installing SPD at some locations merely will not ensure protection. It has to be the withstanding level of the equipment has to be looked into. What kind of wires are coming into the equipment and where they are coming from, and all these lines are protected or not. So it has to be holistically looked into. The entire wires coming from external or even sometime internal also need to be protected. These are very well explained in the standard, but practically implementing it, the person who does the job, he has to be really skilled. Only a skilled person, a very well skilled person can do this job. If somebody buys it and install it and claim that SPD will protect the entire electronics, most probably during the critical time, SPD may not work. So this has to be done by a skilled engineer. Continue, please.
Okay, we will take maybe three more questions and we'll finish up. Are there any insulation coordination for LV system similar to MV and LV system? No, we do not need to provide an insulation coordination study for an LV system. But when you take an SPD into consideration, there are always coordinated SPDs between level 1 to level 3. And we are supposed to provide a coordinated SPD for our installation, for our low voltage installation.
No, in low voltage, since the working voltages are fixed in a typical situation, example residential, we have the fixed voltage, let's say 400 or 415 volt. Depending upon the location of the electrical installation, categorization, insulation coordination based categorizations are already fixed in the standard CAT 1, CAT 2, CAT 3, CAT 4. So based on the categorization or
Hello, your voice is cut. So basically, what Gopakumar sir is saying is the category is already fixed, CAT 1 to CAT 4. And we are providing the insulation, the equipment manufacturers and SPD guys
from
are
where they are,
providing.
or what is the location of the installation.
Yes. Now, please suggest suitable counter indication in SPD like numbering of surge voltage or impulse voltage. There are separate devices outside the SPD which can be integrated, which will tell you what is the surge current and the surge voltages. Okay, which we also have. And the last question. Okay. Last question. For my application, single phase 230 volt and three phase 440 volt, is there any recommendation to use MCOV range 275 or 320 volt type 2 with MOE technology SPD? Vijay sir?
Uh, uh, 1 second, actually, I just missed the question.
Okay, let me just repeat it. For my application, single phase 230 volt and three phase 440 volt, is there uh, any recommendation to use MCOV of 275 volt or 320 volt for a type
So,
2 MOV SPD?
okay, as sir told that, of course, 320 volt MOVs are better, or 300 volt MOVs are better than 275 volt MOVs, but provided the voltage protection level shall not go beyond 1.5 kV.
Okay.
With if we can increase MCOV without compromising voltage protection level or UP, then it is okay. Higher is better.
Okay. Can we take one more and
Yeah,
finish this
yes,
session?
yes,
Okay.
yes.
In an industrial project where we have PLC and SCADA control system, RIO panels will be in the control room with SPDs in the terminal connection. In the panel and field instruments like PIT, TITs, etc. We will have lead length up to 100 meters. Kindly advise.
So Actually, there are separate field mounted SPDs available for this kind of applications for RIO panels. If there is a, in recap, there is a series called PLP series SPDs. These are specially designed for this kind of panels which are installed in the inside the field. So they have they comes in M20, M32 gland kind of size.
Okay, okay. Okay, we will, okay, we can close our question answers. So Lakshmi, can you
Yes.
take over?
Yeah, I'll take over. Thank you, Anandu and Vijay, for your in-depth, technical session. I think the questions are still pouring in, but best interest of time, I think we can stop. And for those audience who have more questions, I think you can reach out to Anandu and Mr. Vijay through their email IDs. I think my colleagues have entered it in the chat box. So whoever has more questions, please to reach out to them. And thanks to the audience, I think we have nearly 300 plus audience today, and they stayed towards the end also. And the questions also, very interesting as well. Special thanks to, Gopakumar sir for his keynote address. And when I say audience, there are, pretty big names such as Phoenix Mills and Adani, Geo, and other government bodies as well. So we look forward for the same attendance, for the upcoming webinars as well. And thank you once again to all. Just a side note that the webinar will be up on the Cape Electric YouTube site. I think my colleagues will be entering the YouTube link there. So for those asking for the slides and all that, you can please refer to the YouTube site. Thank you, Anandu, once again. And thank you, Vijay, for your time. It's been an engaging session. Thank you, guys.
Thank you.
Thank you. Thank you, everybody.
Thank you.